Good day, everyone. Today, we're going to discuss the vector components, and still we are on the part one, which is the basic mathematical techniques and formula manipulation. Again, if you need to know the other topics for our review sessions in physics, just click the link below, and it will be redirecting you on the Google Sheet. So let's discuss now the vector components. Last time I discussed about what is a vector, and a vector has a magnitude and direction. Examples of vector would be the uh, acceleration, force, and velocity. Now we will gonna limit our discussion in a two-dimension x and y axis, although we have the three-dimension vectors, but this time we're gonna only use the x and y components. So refer to the figure below. So uh from here we have the ay and then ax. So if we're gonna have here the vector a, these can be simply written as like the vector a here. If we have here the vector A, this AY can be transferred here. Let's try to transfer that AY. So this is the AY, and then this is the AX. So take note that this one, it resembles now a right triangle, right? This one, it resembles now a right triangle. And so we can simply have the Pythagorean theorem like this, which is, this can be represented as A, B, and C. Remember that in Pythagorean theorem, that is c squared is equals to a squared plus b squared, or we have the c is equals to square root of a squared plus b squared. Okay? And so this is just the same. Okay? So we're going to have the ax squared plus ay squared. Now, how about this formula? We have the a cosine alpha. Now, if we assume here this is the angle or can be represented as alpha, okay? And so remember that in our trigonometry, we define cosine theta as hypotenuse. So we have the adjacent over hypotenuse. If you could remember your SOHCAHTOA, cosine is adjacent over hypotenuse. So cosine theta is equals to, what is the adjacent side? The adjacent side would be the AX. So this is the adjacent side, and then the hypotenuse is this A. And so if we will replace this with alpha, so AX, that would be the cosine of alpha multiplied to A. And so this is now our component or the horizontal component of the vector. Now remember also in your trigonometry that the sine theta or the SOHCAHTOA, right? Sine theta is opposite over the hypotenuse. And so remembering that, that would be like, if we're gonna replace it with sine alpha, we have the opposite. Opposite of this angle is this AY, right? Opposite of this angle is this AY. And so therefore, that would be AY over the hypotenuse, which is this A. And so we have now AY is A multiplied to sine alpha. Okay, so we have now this vertical and horizontal component. So this is the vertical component or the y component of the vector, and this is the horizontal or the x component of the vector. Now, how about this one? This is for the formula for the angle. So remember, if you can recall, for the SOHCAHTOA, tangent theta is equals to opposite over the adjacent. And so tangent theta, that would be equal to AY over the AX. Now, in order for us to get the theta, that would be the arctan or the inverse of the tangent. That would be AY over AX. And so replacing theta with the alpha for our symbol, then therefore, this is now our general formula. Okay? Now, let's look at our example here. For us to better understand that, let's look at example here. Find the x and y components of the resultant in the figure below. The resultant is 100 kilometer long at an angle of 60 degree from the east of positive x-axis. So this one is 60 degree, and so this one is 100. So the value of our Rx is cosine theta, right? And so our R is 100, and we have cosine 60 degree. And you've noticed that the cosine of 60 degree, we now recall these values in the trigonometric table, 60 degree, and then we have here the 1/2, right? So we have here the 1/2. Therefore, we have cosine 60 degree is 1/2 or 0.5, and 100 times 0.5 is 50 kilometer. Now, how about the R value or the vertical component value? So we have the Ry, which is R sine theta, and the sine of 60 degree is square root of 3 over 2, right? And so sine 60 degree is root 3 over 2, and therefore Rx is cancel the 150 and 102, so this one would be 50, and so the final answer here is 50 multiplied to root 3 kilometer. Now, most of the time in the examinations, it will be left like with square roots. So the choices will be, or we will be having square roots. Now, let's look at our next example. Example number 2. Vector B is the sum of the two resultant vectors in the figure below. Which of these is the length of vector B? Okay, so vector B is the sum of the resultant vector. Which of these is the length of vector B? I think the figure here, I think the figure here is just like it has been erased. So let me just re-edit it. So that would be 30 and 40. And so what is the length of this? So remember, we used the Pythagorean theorem for this because B will gonna represent as the hypotenuse, and this is the formula. We have here, we have the 30 square plus 40 square, and then that would be 900 plus 1/6, and the square root of 2,500 and equals 250. So the answer here is letter A. Now, I would encourage you to memorize the Pythagorean triples. So this one resembles 3, 4, 5, so 30, 40, and 50. Now, these are the Pythagorean triples. You can take a screenshot out of these. So this will be helpful, especially when you will be taking your examinations. So what are these automatic Pythagorean triples? We have the 6, 8, 10, 7, 24, 25, 5, 12, 13, 20, 21, 29, and 8, 5, and 17. So these are the common Pythagorean triples. Okay? Now you can memorize this part, but I would say that this one are the most common Pythagorean triples that's being asked in the examinations. Okay, now let's look at number 3. A ball is kicked with an initial velocity of 100 meters per second at an angle of 30 degrees. What is the horizontal component of the ball? So here, if you're gonna look, what is the horizontal component of the ball? So horizontal component can be, we are asked for the horizontal, meaning to say for the x component. So we will gonna be using cosine. So Vx is 100 cosine 30 degree, right? And what is cosine 30 degree? Cosine 30 degree. Now let's go back to our values here. Cosine 30 degree, that would be square root of 3 over 2, right? So square root of 3 over 2. So let's go, let's go back here now. So again, 100 times root 3 over 2. Therefore, our Vx here is 50 multiplied to root 3. Okay? And so our answer here is letter C. Now, how about example number 4? A box is suspended by two ropes which has 30-degree angle. Each rope has a tension of 10 Newton, and the weight of the box is equal to the two vertical components of the rope. Now, look at here. Even though you have no idea how to solve for the force, but here it says the two vertical components of the rope. So if we're going to think out of it, we have the two vertical components of the rope. And so this one is 30 degree, and then this one is 30 degree. So if we're gonna redraw the figure here, so this one is 30 degree. This is the vertical component of this is the first one, and so this would be the vertical component. And so we were gonna use the sine, right? We're gonna use a sine. And so if this one is 10 Newton, so that would be the vector. So we're gonna have sine of 30 degree multiplied to 10 Newton. And what is sine of 30? Sine of 30, if you could recall, that is 0.5. So 10 Newton multiplied to 0.5, and then we will gonna be left out with 5 Newton. Now take note that it's just the one component, which is the 5 Newton only. There's other rope, right? Two vertical components of each rope. So since they are just the same, so we have now the 5 Newton plus 5 Newton, and that would be letter B, 10 Newton. Okay? Now, I would encourage you to look on the uh, practice set. Okay? So you may take a screenshot out of this and try to answer the items 1 to 6. So this number 1, number 2, number 3. And then this one is number 4 and number 5. You can take a screenshot or pause the video. And this one is number 6. Now, if you want to know the solution out of this, you may visit our Google Sheet and then click the link so that they will gonna direct you on the solution video out of this. Thank you for listening.